velocity time Vt graph. Objective: to plot the velocity time Vt graph for an object moving with uniform accelerations from a given set of Vt data and to determine the acceleration of the moving object and the distance moved by the object. Materials required: a graph paper, a sharpened pencil, a scale. Procedure: examine the data given below for the motion of a car. Observe the velocity v of the car at different times t. Notice that the velocity is in m by s and the time taken is in seconds. Find the range of the velocity and time. Take a graph paper. Draw two perpendicular lines OX and OY to represent x-axis and y-axis respectively. The point O where two axes intersect is known as origin. Count the number of divisions available on the graph paper along the two axes. In a typical graph paper, each of the larger box corresponds to a 1 cm by 1 cm square, which is subdivided into 100 smaller 1 mm by 1 mm squares. Now choose which quantity will be displayed along the x-axis and which along the y-axis. Conventionally, the x-axis represents time and the y-axis represents velocity. Select an appropriate scale based on the available divisions on the two axes and ranges of the provided velocity and time data. According to the scale you have chosen, mark values for the time and the velocity on the respective axes. Mark the time 5s, 10s, 15s on the x-axis at every centimeter from the origin O. Similarly, mark the velocity 10 m by s, 20 m by s, 30 m by s on the y-axis at every 1 centimeter from the origin O. Mark the points on the graph paper to represent each set of values for time and the corresponding velocity given in the data provided. Join all the marked points on the graph paper to obtain the v minus t graph of the data provided for the motion of a car. Check if this graph is a straight line. A straight line graph indicates that the car is moving with a constant acceleration. This graph can now be used to find the acceleration of the object and the distance moved by the object in a given time interval. Determination of acceleration of the object. To determine the acceleration of the car, consider any 2 points on the straight line graph and find their corresponding velocity v and time t values. It is better to choose the points that correspond to integral values of time and velocity to simplify calculations. Let the selected coordinates be t1 v1 and t2 v2. Calculate the acceleration of the car as the ratio of change in velocity v2 minus v1 of the car to the corresponding time interval t2 minus t1. A is equal to v2 minus v1 upon t2 minus t1. Similarly, determine the acceleration of the car for another time interval by choosing different sets of points on the Vt graph. Observe that we get same acceleration. This shows that the object is moving with uniform acceleration. Similarly, determine the acceleration of the car for 3 more time intervals by choosing different sets of points on the Vt graph. B. Determination of distance moved by the object. For a given time interval, the area under the velocity time graph gives the distance moved by the object in that time interval. The distance s traveled by the car in a time interval T2, T1 will be given by the area ABCDE under the velocity time graph. That is, S is equal to area of rectangle ABCD plus area of triangle CDE. Let us now determine the distance travelled by the object between 5 and 10 seconds. Calculate the distance travelled for 5 seconds. Repeat calculation of distance travelled up to final time. Observe that the distance travelled by the car given by area under the graph increases with time for the same time interval of 5 seconds. Results. The velocity time graph for the motion of the car in the data is a straight line graph sloping with the time axis. This indicates that the car is moving with a uniform acceleration. 2. It is observed that the distance travelled by the car in a given time interval but at different instants are different. This shows that the car is in accelerated motion.